want to see what happens when we don't change anything, adding or subtracting out here, or adding or subtracting inside. We want to see just what happens when we put a 2 here. Now, your t-table can get really big really quickly, so we're going to do -2 to +2. And I don't know that we'll graph all of them. We'll just see how big our numbers get. The t-table we're going to do is x f of x, and we're going to do -2, -1, 0, 1, 2. -2, you would take the absolute value of it, which would be 2, then you multiply by the 2. So I would have -2 would give me 2, and the f of x, the y, would be 4. -1 will give me 2 times 1. 0 will give me 2 times 0. 1 will give me 2, and 2 will give me 4. We talked about that v being very symmetrical. I'm just going to plot them. You can plot them from your t-table. -2, 4. -1, 2. 0, 0. 1, 2. And 2, 4. See the symmetry of those points? If you fold it on the y-axis, you'll see that it would be the same on both sides. Absolute value always graphs a v. Always. Just like y equals mx plus b always graphs a line. The vertex, just like the parent, is 0, 0. But that might not surprise you because there was nothing added or subtracted out here like in numbers 1 and 2 graphs, and there was nothing added or subtracted in here like in number 3 and 4. So it's going to look location-wise more like the parent, but there's a big difference. I say thinner, I say skinnier. It's actually, I think last year we wrote thinner. In case the 2 on the outside pulled it in. We can see that. And if you remember from geometry, when we did dilations, we would talk about, we'd either make them bigger or smaller. And sometimes in Algebra 2, we call them dilations or contractions. I think they were just called dilations in geometry. But they had scale factors. So the scale factor is 2. And again, that 2 is what's causing this to happen. It's very similar to slope, but it's not slope because it's not line. It's actually like 2 lines put together. So when we start shortcutting this and not doing this, I'll show you how that works. Number 5. So let's do the same thing, and let's do f of x is equal to 1/2 absolute value of x. I'm going to do -2, -1, 0, 1, 2. So you're going to take the absolute value of it and then multiply by 1/2. So the absolute value of -2 is 2 times 1/2 would be 1. Absolute value of -1 would be 1 times 1/2 is 1/2. You could do 0.5. I just leave it as a fraction. 0, 0 times 1/2, 0. 1's going to give me the 1/2, and 2's going to give me the 1. And we've got -2, 1. -1, 1/2, 0, 0, 1, 1/2, and 2, 1. Now, fatter is probably not politically correct. So last year we said wider. Now again, you're comparing it to the parent, not to number 4, but you're taking them. The vertex is still 0, 0. And then number 7. And we're going to put, there's an understood -1, a +1 out front, so we're going to change that to a negative. I think we can just do these 3 numbers. Let's do -1, 0, and 1. Now notice the -1 is outside. So we're going to take the absolute value of this number and multiply it by -1. So 1, when you take the absolute value times the -1, will give me -1. 0 will give me 0 times -1. And 1 will give me 1 times -1, which is -1. So you've got -1, -1, and 1, -1. it different from the parent? Remember what we call that in geometry? A reflection. And it's the reflection across the x-axis. Because that negative's on the outside, it opens down.